Hello everyone, and welcome to our webinar dedicated to Scylla Intrusion Detection and Perimeter Protection System. Let me start from a round of intro. I am Ara, co-founder and lead data scientist at Scylla. And Scylla, well, detailed information is presented on our website with all the details on products that we offer available here. But in short, Scylla is leading developer and provider of AI-based facial, object, and behavior recognition tools for security and retail operations. It augments the relevant industry with next-generation AI solutions that help to minimize costs, avoid human factor errors, and provide new tools to increase security and effectiveness of operations. Today, I'll walk you through our intrusion detection and perimeter protection system, explain the way it works, its features, strengths, and limitations with all the recent developments. Let's start from the very beginning. IDS, the name of this module, means intrusion detection, and also there's this part, the perimeter protection system. Initially, it was the intrusion detection system only. Now, do not be misled by the title. We are not going to speak solely about the detection of intruders. It's just historically happened so that we started developing this series of products from intrusion detection tool. Then later, it transpired that not only can we elaborate on it and make it more powerful in very different ways and add features and make it much more interesting, but also the AI engine we used for IDS, intrusion detection, can be, it turns out it can be applied for solutions with similar goals and functionality in other fields. So we decided to keep the abbreviation to make sure the broadened content is accessible and clear. So let's start with IDS itself, the way it works and what it stands for and what it does. Intrusion detection and perimeter system, well, those of you who have dealt with modern IP cameras, almost any brand, any model, those who ever set up one for home or commercial use, or merely browse through settings, are most likely familiar with features like motion detection alarms, right? Or maybe even more sophisticated terms like virtual fence, perimeter protection, or similar. So the cameras typically can do such tasks embedded by the software that is embedded, like the software they come with, right? And they will detect anything that moves within a certain area and inform the owner by one of the alerting schemes. Typically, it's like sending an email or through dedicated apps they come with. Now, this may sound cool and fancy and everything, but in reality, the alarms induced by embedded software are, well, predominantly false. They are caused by in many cases, they are caused by moving shadows, wind-moving objects, animals, and even indoor. What I named, like, this applies mainly for outdoor cameras for the yard and everything, but even indoor, a car light that shines, like a passing car light that shines through a window, can also trigger the alert. So I'm not even talking about the cases where motion-based alarming is not even possible. For example, there are these cameras, PTZ cameras, and PTZ cameras that are, well, they are placed in one place, but they overview a quite large area because they also move, right? So, of course, by definition, these type of cameras, as well as the cameras that currently are can be installed on drones or other moving objects, they cannot be, of course, motion detection cannot be applied to them, right? And also, so eventually one ends up receiving dozens of false positive alarms daily. Well, this results in annoyance, time loss, unnecessary panic, and eventually leads to turning off the functionality altogether, right? So what Scylla offers to overcome these issues? Now, here I usually bring up an analogy with typical household device like a DVD player, right? This is what people mean by embedded software, right? It is designed and assembled to do a very specific but limited number of tasks, and once the technology takes a step forward, then the device can be tossed away. For example, like CD players, etc. Well, they are no more usually, let's say, no more in the household. At least, well, I don't have any of them, right? In comparison, Scylla is more like Netflix rather than a simple DVD player. Not only does it perform the job better, but the smart AI behind intrusion detection allows us to filter up to 95% of false positives, thus saving our customers time and money. And also, well, this number of accuracy rises as the model gets smarter and smarter. And again, the ideas, not only it comes with conventional functionality, like defining the zone of intrusion and schedule of the alerts, but also a possibility to specify, for example, the object of interest. You can specify if you're interested in human or vehicle or both at the same area, right? So, and then even there are some add-ons that you can add to the system. For example, you can run the suspected intruder through Scylla proprietary facial recognition system and get the identity of the person if the face is visible, right? So, and moreover, Scylla gives a possibility to get new features as the product is developed and upgraded. So it's not a solid state software or embedded software. It can get smarter, it can get new features on the same hardware base, right? I will talk about these new features that I'm pretty sure you will like. Okay? So compared to alternatives in the market, what can Scylla IDS offer, right? Scylla IDS includes a much wider range of powerful features, right? Such as, for example, social distancing monitoring, real-time people counting, flow counting, with the possibility to set occupancy thresholds and configure zones for counting density. I will talk about this in detail. I will even show you a demonstration of how it works, okay, a bit later. In addition to that, one can also detect cases of loitering as well as running in the view of the camera that can be detected and can trigger specific alerts that you can get on the dashboards or mobile applications. And again, I will talk in detail about this shortly. I will introduce all of these features. And well, speaking about the differences from alternative products, I will mention a few major ones to begin with, right? So first of all, as I said, Scylla is based on AI, well, computer vision object detection module, which means that it's not only like viewing seeing the motion, the differences, but it also specifically looks for a person in the view. And again, don't be misled. I'm not talking about the full person, full body, but like a body part will do also. If you put your hand in the view, that will still trigger the alert, right? So as it is, as the object detection algorithm, the object detection based approach allows Scylla IDS to work on cameras with moving background, such as above mentioned PTZ cameras, okay? Cameras that turn around and maximize their view. Or it can be used on body worn and drone mounted cameras also. Naturally, features like intrusion alerting is not possible on these type of cameras. as I explained. So meanwhile, Skyla IDS is invariant towards challenging conditions such as fisheye lens distortions. For example, it can work on fisheye, impaired illumination or noisy pictures from somewhat. There can be cases that the picture is coming already like with some distortions, with noise. Well, Skyla will take care of that. So, and also it can be easily integrated with the camera network that your area, private, retail, or any municipal, whatever area is already equipped with. I will again talk about integration and the easiness of it. Okay? And of course, among the main differentiators is the accuracy. Accuracy is the key for us, of course, not only for safety related solutions, but also for use cases that branch out, such as business analytics. Right? Scylla IDS can be used to understand how customers move around the store. It allows users to build customer or employer heat maps, track where they linger, where they which areas they are drawn to, and even which products they pick up and put back to the on the shelf, back on the shelf. Moreover, Skyla can even spot potential shoplifters in another module that is called anomaly detection solution. I will talk about it. I will present it on a separate webinar. That model is analyzing the action of people in a view. So, well, features like advertisement, distribution, placement, customer flow control, public area management. For example, there's a use case that based on movement of customers and employers, public area can be like light illumination and heat cold, like AC control, can be regulated to suit better the needs of customers. So that can be all allocated based on the actual information provided by Skyla IDS, right? So, and again, I will remind you, do not be misled by the abbreviation, intrusion detection. It just so it happens that this same model can be modified to work and do all of the above mentioned tasks, right? So, and of course, all this information can be time gated to show time-lapse changes throughout the day or week or month or whatever. These smart augmentations are designed to turn stores into a more integrated, data-driven environment where cameras provide safety to customers and employees and allow store managers to do their job, taking some heavy-duty routine task off their shoulders, like person counting or occupancy counting or whatever, right? So the technology may save money and offer additional business benefits, but the primary purpose is taking care of customers and stuff, like the security, right? So, and therefore, here I will specifically mention that customer tracking comes with a built-in protection, but just I want to assure you that the tracking, it's proprietary algorithm that is not based on biometrics or not based on facial biometrics. It's not based on face recognition. In fact, the face can be even not visible, hidden, etc., and it will still and Skyla will still do the job, right? So no images are stored or transferred from one location to another. Even when Skyla is implemented to track a person through a facility using different cameras. So imagine you have to find this person here and then track while the person is going from camera to camera. Even then, the image is not transferred from one camera to the other. It's done a different way. There's a so-called feature some features, some numbers are transferred, but that has nothing to do with the appearance of the person. You cannot revert back and get the appearance of the person, even if you somehow intervene and catch those numbers somehow, let's say. Okay, so what happens is that after detection of a person, the overall appearance of him or her is being deciphered into so-called feature maps, as I said, irreversibly. This process is irreversible, and it transcodes into a set of numbers that are later used for recognizing this person elsewhere, and track and build individual customer pathways. Valuable data, actually, which is craved by many retail business managers. So if I'm asked to name the main technological know-how that puts Scylla ahead of alternative competitors in the field, I will highlight the proprietary object detection, which is our own and works flawlessly, and proprietary tracking algorithm, again, another point of our pride, let's say. And these are the algorithmical foundations of our exceptional accuracy, and these are again developed and tailored specifically for the solutions listed above. Okay, and taking into account they take into account the specifics of the data, that they will be working on a video stream, so all of the peculiarities are taken care of. Like the frames can be blurry, and we are talking about person or car or vehicle tracking, etc. All of this is taken into account, right? So another one stronghold is the flexibility. So not only the flexibility, versatility of the software itself, but that like versatility towards inputs and outputs, all quite some types of video streams, most of them are covered. Flexible requirements toward the hardware. I will talk about hardware at the later parts of this webinar, but also the company attitude related flexibility, I would say. To explain the last statement, let me put it this way. We are a company that used to be a startup just recently. We still keep the agile and flexible attitude towards the solutions and our customers, instead of the rigidness typical to big enterprises or corporate. And we can adjust the solution here and there to cater to the specific needs. Okay. So lastly, all Scylla solutions can be installed, and this is about versatility of the architecture. They can be installed either locally or cloud hosted. And I will speak about this installation architecture later on. Okay. So, okay, enough introduction. Let me show how intrusion detection works in real life. All right, so here I am. We'll demonstrate you the intrusion detection system in live. And yeah, let me dim the light a little bit to mimic a real life scenario, something like that. There you go. My colleague is already demonstrating that. So yeah, so what I want to also show you is the following. The system is, by the way, set up to detect intrusion only in this perimeter of the doorway, right? In this light area. So what happens when there is a motion? Well, nothing happens, of course, because it's not a motion detection system. It's intrusion detection. But the moment I am passing by, yeah, the system understands that it's a person, and there you go. The alert, the frame that you see above, will be sent to the alerting the endpoints, the alerting dashboards, to the mobile reporters, and also the system can trigger any access control system that it's attached to, that it's connected to, close the doors, light up, fire up the siren, etc., etc. So that the system is capable of doing the whole thing. And again, it's not just a mere motion detection system, right? It's pretty sensible to the objects. In the current setup, it's people, a person, and also the system is able to detect vehicles, different types of the vehicles. All right, let's get back to the presentation. Okay, as I said earlier, this was the simplest function of IDS based on computer vision assisted person detection algorithms. The rest of the functionality, such as heat maps or loitering detection, would take more time to trigger and demonstrate. You can find full info on those on our website. And now I will introduce a model that is a derivative of the intrusion detection system. It became popular recently due to developments and changes imposed by COVID-19 pandemic. It's called occupancy counting. As you will see here, in parallel with person detection, and in somewhat more importantly, we use person tracking. As I already mentioned, the spread of COVID-19 forced governments to apply restrictions and rules to minimize the impact it caused. It's mandatory to regulate and limit the maximum number of people allowed in closed spaces in several countries. And to do so, to regulate, to count, usually managers hire people that stand at entrances for a whole day, manually and carefully counting people as they enter and exit. Things get harder when there are multiple entrances, exits. The information needs to be synchronized all the time, and a mistake made by one affects all, etc., etc. So, as one manager of 500 stores chain confessed, counting manually and accurately is a nightmare, actually. You can't really count people for hours, days after days, and it's boring. And it's expensive. Tasking a single staff member to watch the door at all stores for 1 hour a day would cost $3 million annually. For this chain, and having someone outside for 10 hours a day would cost even more, right? So what Scylla offers is an automated people counter, a system that utilizes our person detection and tracking engine and counts entrances and exits from any number of cameras. That might sound an easy task, but if one considers all scenarios that can happen at the entrances, challenges become obvious, and in many cases not solvable by embedded low profile solutions on the camera. And so you are bound to use full power of modern AI capabilities. So I will explain you what this image shows some challenging problems that can arise. So the hardest parts when most less complex solutions get confused are cases when people pass in front of each other. It is also hard not to make mistake when people do not move in rather straight lines, but let's say loiter in areas set for counting, like in this case for pathways Z and K. To do counting accurately, especially for places where crowding, queuing, or short-term loitering is possible, and which is the case usually at the entrances. People, they just stand there or wait for each other, etc., or even, I don't know, close the umbrella or whatever. So the solution must have a very accurate tracking mechanism integrated, and otherwise mistakes are inevitable. And as the counting mistakes zoom up, in the total count throughout the day, the bias can be critical in the afternoon. So the mistakes are zooming up, and then at the end of the day, you can have, like, imagine you do not allow additional 50 customers into the shop because your system miscalculated at the end of the day, and you think you are above the limit, right? So yeah, that is a painful task. I mean, automation of people counting, pretty tough. To deal with this challenge, we developed a state-of-the-art tracker that tracks each customer who enters the the view and can understand if for example the same person gets shortly in and out in the camera view, like for example in these cases here and here. It automatically gathers data from multiple cameras installed at multiple locations, and it shows the consolidated common the result on the mobile alerting applications. And for example, if you want to use numbers derived by the system for other analytics, and I'll speak about this shortly, Scylla IDS will be more precise than the possible analogs solutions out there, right? So, and this statistical analysis, the daytime distribution of occupancy and visitors, and all of these are just invaluable additions to the information about your business, your retail store, or even some other business of the sort. So let me show you the occupancy counting demo here and explain. All right, so another solution that I would like to introduce in life is the kind of deviation, a branching from intrusion detection solution that we provide. This one is called occupancy count, and it does what the title says. Basically, it counts people that enter and exit the premises through specific areas that are controlled, that are under surveillance cameras of some sort. So basically, the way the system works is it tracks each and every individual that's in the visible area, and this tracking is very important for the accurate count, because you can see, for example, especially if you want to keep the track of in cases of entrances and exits separately. For example, let's imagine that somehow is of importance to you. Then what the system does, it kind of understands that the same person, for example, I will show you when I'm out of the view and then I enter the view, then the AI understands that's the same person. So for short-term exits, it would still not count as an entrance. So as you can see, the occupancy count didn't change. But for the longer period, if I did enter the premises, then the count will change. So this is not only this feature is in itself is an addition, but also for the accurate counting, especially if you have an experience with this kind of embedded solutions, you know that there might be some cases that I've also shown in the previous slides, that when a person is loitering or lingering somewhere in the middle of the screen, and or also close to the passage, close to the crossing line, then this might trigger the count several times and bias the overall assume. So to avoid that, you really need this sophisticated tracking in place that will keep the track of each and every person separately, and will count only the real cases of entrances and exits. All right, so this was it for the demo in live, and let me get back to the presentation and continue. All right, so Scylla occupancy counter can be adjusted to measure the time people spend in front of the cashier to access customer service, the time employees spend in specific areas doing their jobs, etc. For instance, it can be used to detect cases of loitering. One has to define the area, the maximum reasonable time of lingering in that area, and as soon as someone is detected to spend more time than the threshold, an alert will be created and sent to dashboard, and and the other endpoints that are configured. Right. Similarly, a minimum time of passage can be defined to detect cases of running through the area, and again with corresponding alarms. Heat maps, I already spoke about. Occupancy per zone, center of mass maps, where people gather most, around which areas they gather the most, and statistics on crowd flow pathways. It's all of this is provided by the same engine. Okay, so a lot of cool stuff that can be tailored to customer needs, and the reports that can be tailored. In addition to the real-time data, Scylla Analytics can also provide hourly, daily, weekly reports of the above listed metrics. So, and by the way, this solution is among the easily post-COVID transferable ones. Even after the pandemic ends up, hopefully, the maximum occupancy requirements and the statistics, day, week, month through distribution of statistics would be the information that the marketing manager would desire, definitely. Okay. So now for all the presented solutions, the subject of interest was a person. At least I gave you these examples with a person, a human. And similar solutions were developed and implemented for vehicles and related use cases. I will go through several of them so you understand the possibilities and branchings of the product. For example, vehicle detection is used in one of our solutions that is focused on intelligent traffic management. More specifically, smart or automated parking management. I will introduce it as an example of a real use case installed and working up and running in a number of cities in India. We call it a smart parking solution. We developed and customized the solution specifically for the needs of the client who is managing a parking system in these cities. So what does it do? Well, by using IDS computer vision engine, it first time gates the entry and exit of vehicles into the designated parking spots. This information is later used to charge the drivers accordingly. It detects if a vehicle of the wrong type is parked in the area, and detects if the vehicle is parked in a not designed way, in a wrong way, and not, let's say, not parallel to the lines or out of the lines, etc. Detect if a vehicle is parked in an area which is restricted for parking, and also there might be parking for two-wheelers where four-wheeler will occupy, or vice versa. So this all things will be detected and reported. So all of this analytics is in this particular architecture. They are done on the edge. As the model is installed on small factor hardware that analyzes several cameras in particular area. I think like something like 40 or 50 cameras are analyzed by a single small factor. I wouldn't call it a server, but essentially it is kind of a small server. And then this small server, Scylla server, is sending reports to a centralized dataset server that consolidates all this data from different parking slots, etc., and shows up all this information. This consolidated parking and violation logging database is shown on a dashboard, and which later is used to monetize the service, parking service or tickets, etc., etc. I'll show you a short time lapse of generated images. It was generated for demonstration purposes. Here you can see the occupied parking layout in white. Wrong parking is marked yellow, and parking violations are marked red. By the way, here too we use our object tracking algorithm to eliminate cases when short-term obscuration could have triggered wrong alerts. If someone is, let's say, coming in front of the two-wheeler of a bike and passes by, or a car next door or something, across the street is obscured by a big car, bus or something, when eventually it opens up, then we still understand that it's the same car, it still stands there, it didn't go anywhere, etc. So tracking here is also used for different purposes, but still. And similarly to people counting, the occupancy counting, we can also count vehicles that enter and exit through specified pathways. Actually, this model was developed much earlier than the person counting model. The latter was adapted, later it was adapted as per use case requirement. The system was developed to aid intelligent traffic monitoring, as the number of the vehicle flow can be used to intelligently affect the traffic light opening times, alter them, and minimize traffic jams on road load on important roads by real-time analysis of current situation, the actual current situation. So cameras placed above roads calculate the traffic flow per lane, report the number and type of vehicles in real time, provide enriched data for analysis, predictions, statistical analysis, historical, and corresponding traffic control. Here is the demo video, and you can see the recording of the dashboard from one of the cameras installed. Actually, this one is installed in Minsk, Belarus. The reporting from it is connected to a centralized server that smartly controls the traffic lights at the crossroad based on this real-time information. Okay. And now I would like to speak about a topic that often pops up in our conversation with clients when we discuss the actual installation and usage. I'm talking about integrations. People want the system to be as easily integrated as possible with minimal disruption to their existing solutions and flows. At Scylla, we already developed sophisticated integration schemes with major VMS providers such as Milestone, Genitech, 9X, etc., several others. To those, these are VMS, right? To those who are not aware, VMS is a video management system that allows users to automatically connect to devices like cameras, configure dashboards, show like desired video streams, chosen video streams to save them in a constant loop or at a specific schedule, or detect a specific event and save the video surrounding that. So this whole thing can be done on a VMS. So the saved playback data can then be viewed to detect anomalies that occur or require attention. Okay, so similarly, video management system allow users to extend their default functionality by integrating custom solutions that aim to decrease human intervention and help reduce efforts in getting useful information by automated video analytics compared to manual analysis. Ideally, the custom solution would use VMS functionality and send the gathered information, such as alerts and statistics, back to the VMS dashboard to be accessible for the user. That's what we call full two-way integration, right? So one way is when you just simply use the video feed from VMS. You just get the video feed, do something, and then report separately. That will be one way. That is much easier, by the way, than two-way. When two-way, you need thorough integration, and you actually depend on VMS provider. But typically, especially good VMS providers, they provide also SDKs and APIs to facilitate this process of integration. And eventually what this means is that Scylla components, not only IDS but other solutions that we provide, they can be running separately but there will be a two-way communication. We get the video from VMS, not from cameras, because they already come to VMS. To minimize the traffic, why would you want to take the video 2 times, right? So we take the video from VMS, and then we report back to VMS. We report, and the user, the customer, will see everything that is need to be shown on the VMS dashboard itself. Okay. So now I will introduce this type of an integration, such an integration on the example of world-renowned system Milestone. It's called Milestone. Okay. The following chart shows the scheme of the integration pathways. Specifically, we find Scylla server on the lower right here, where all AI analytics is done. Well, for example, intrusion detection functionality. It communicates with our Milestone VMS plugin through VMS plugin, the two-way integration, meaning that it gets visual data from VMS, as I said earlier, and processes it on the server, and then returns the reports, the alerts that the user can see on the same screen of the VMS. Okay? In one of the implementation scenarios, Scylla IDS depends on motion detection events generated by Milestone VMS, and the recordings are triggered by detection event. So what happens is the following. Milestone also has a motion detection system. It can analyze, and whenever it sees a motion, there will be an alert. But as I said earlier, there are as many false positives as like more than enough to get annoyed. Then what Scylla does, it filters these events, these motion detection events, and leaves only those where Scylla can see a person in the sequence that Milestone is sending to Scylla, right? So every motion detection event, at every motion detection event, plugin will process several frames, and if it finds a person, which is we call it an intruder, then it will generate an appropriate alarm that will pop up on the VMS dashboard and draw the attention of the supervisor. So yeah, and I will show you the video how it looks and how it works. So as you can see here, the detection of a person triggers an alert. The alert in this case is set up to be shown in Milestone dashboard as a log, simply a log line, and it is accompanied by the frame as well as the video, 3 seconds pre and post the event. So overall, like I think it's 6 seconds here, that shows what, let's say, what triggered the alert. Okay. So of course, these events can be configured in such a way that they are enabled at a specific schedule and a specific area of the view, and the pop-up can be much more, let's say, vibrant and visible, etc. So all of this can be configured in a very, and we can connect to external devices, external alerting devices, access controls, and we in one of the implementations we connect to LED lights, green, red, etc., to differentiate between within a schedule or out of schedule events. Okay, so yeah, and similarly, any event and information report that Scylla IDS triggers can be sent to VMS in the form of an alert or information log. Not only particularly intrusion detection, but other events too. They can be sent to VMS and can be shown on a VMS dashboard. Okay, so yeah, and again, this was an example on Milestone. Other VMS systems, they are integrated pretty similarly. There's some kind of a intermediate plugin that is responsible for in and outs, okay, inputs, outputs. All right, so now let's say the dark side. At the end of the webinar, let's speak about one of the most favorite topics of our customers, the limitations. With all the flexibility and versatility of the solution, some factors are still to be considered when designing the implementation. And most of those are related this way or the other to the hardware to be used. And so even though we are versatile and very kind of agnostic, but still there are limits. Okay, so let's go over the units of the solution, starting the limiting units, let's say, starting from cameras. Let me assure you that in most cases we are quite camera agnostic. To request on camera models, I usually bring up the following two requirements. First, the camera VMS should have a digital output. Well, naturally, we should be able to get the video streams in a digital form. And second, as a rule of thumb, if a human being can spot the event you saw after, you seek for, then Scylla IDS surely will. Okay? If you can spot the person, then the AI will do that too, for sure. At the end of the day, camera characteristics that would matter can be divided into the following sections. There are some obvious ones, and there are like some non-obvious ones that are even sometimes harder to get unless you are a developer of the camera of some sort, like hardcore. They are hidden, they are not announced in datasheets, etc. So in the obvious ones is streaming interface. That's the streaming protocol, and usually it's one of the ones that are mentioned here: RTSP, RTMP, HTTP. Of course, we cover all of them. Resolution, typically we require minimum HD, and that's quite reasonable requirement. And nowadays it will be, you will have hard times finding a camera that has lower than this. So HD 1280 by 720 is the minimum resolution of cameras. Actually, normally nowadays the full HD is the standard minimum, but maybe you have kind of older versions, some here and there. Okay, and frames per second, FPS, minimum that should be 5, and bandwidth, well, again, depends on the encodings, etc., but typically I like to see minimum 1 megabit per second. Okay, and of course, if we're talking about night, like dark area implementations where there should be an IR illumination and IR vision capability. Okay, so these are among the obvious ones that you can find in a spreadsheet. Not obvious ones are harder to get, and maybe usually people omit them entirely. That's so-called shutter speed, which defines, which is basically, let's say, how much time a camera spends to gather light for a single frame, let's say. I'm simplifying the explanation, okay, not to overburden with technical details. So let's call it shutter speed. It defines how crisp each frame of the video stream is. So the same camera, similar cameras can have same resolution, same FPS, even same bandwidth, but the frames of one will be crisp, sharp, very visible. The other one will be not good, and yeah, that will be based on the matrix, the way it is treating, it gathers information, etc. And noisiness. There are a number of factors. I mean, actually, I listed here very limited factors, which are, not to go too much into technical detail. Basically, all of them, they define the quality of the camera. Okay, so it's noisiness or pixel crosstalk. There is this type of a thing, or anyway, I mean, I don't mention the durability of the camera or lens cleanness, etc., etc. So all of these, they do matter, of course, right? So, and one of them also, like streaming latency. all of IP cameras, all of them have some latency. So they have some lag between actual event and the image that gets, for example, to Skyla also, or on the dashboard. It can be fraction of a second, half a second, for example. It can be up to 2-3 seconds in some cases for worse cameras. Okay, so and again, all of these characteristics are to be considered, and some of them are to be tested on site empirically, especially if you require some camera model comparison. Okay, so but overall you will be surprised by very modest camera requirements and the flexibility of Scylla, which I mentioned earlier, that compensates for possible drawbacks with the power of AI. So even if again, even if it's not that sharp, etc., but still, especially again going back to the rule of thumbs, if you can see that, Skyla AI will do. And concerning the hardware, I will speak about architectures, because they also the architecture defines what hardware you will require. So we have these several options: local, distributed, where an example of that I already shown, that for example it can be small factor, not even a computer, but one of the, let's say here, like Jetson family. These are the small factor, some inches width and height PC that can run the analytics from one or several, 2-3 cameras, and then it will send only the results of analytics to the centralized dashboard. Or you can have even small factor server, like tiny 1 foot by 1 foot, something like that, server that it can analyze something like 15, 16 or 20 cameras on site, and again send the results only to further destination. Also, this can be local distributed. So each and every camera can be connected directly to this unit. It can be local centralized. So if you have, for example, a server room and you have any way, usually that is the case. Actually, this is the most abundant and the most frequent case, because almost any retail or private sector, whatever, they already have some kind of CCTV system installed. So they already have a network of cameras. They already have a server room with servers that are running there and storing the information, recording the videos. So the network is already there. That's what we call local centralized. By adding a dedicated server that will be running Scylla functionalities and attaching it to existing network, we basically get the streams to Scylla, and then you can have the results back to your whatever dashboard or whatever. Okay, so and the requirements here are very, very modest. I could give you some examples, but just like to begin with, just to give you an idea. So because I'm naming stuff like servers or server room, etc., and that might scare some of you, but just for your information, your idea. The notebook that I'm using, well, it's a gaming PC with some GPU inside, but this notebook can analyze for intrusion. This is 18 streams. 18 video cameras can be analyzed on one single notebook. Okay, so if you have, let's say, I don't know, 100 cameras, we are talking about one single server in your server room. Okay, so and eventually, and the last option is a cloud hosted. Of course, you can have the system running on a cloud. The question here, the task here will be streaming the videos to the cloud, so they can be analyzed, and then you get the reports, alerts, or whatever analysis back to you. Okay, so in short, again, local distributed. This can be running on one of this computational units, AI friendly. For example, Intel stick computational stick, or one of the NVIDIA Jetson families. This is the local distributed, and then local centralized. Here the requirement will be that this workstation server should be equipped by NVIDIA GPU, because our AI analytics runs on NVIDIA GPU, and it should be running actually Ubuntu Linux OS. Okay, and for cloud hosted scenario, I would just say that well, first of all, you wouldn't care about hardware specifics, because, well, it's cloud. That's the only thing you want to know. What happens there typically is out of your concerns or worries. Okay, so one thing I would outline here is that our solutions themselves are cloud agnostic. They can be deployed on any major cloud provider, and the customer will need to provide the frames or videos sent to like that will be sent to the cloud, and this process can be done either by so-called port forwarding, so the camera is available to the cloud. No, actually, this solution, this part way is not that favored. And another way is through running so-called connector software of Scylla, which takes a local stream from a local camera, encodes it, and with encoded packages, it sends to the cloud. Then it is deciphered on the cloud, and it is analyzed. So this is also possible. This is also another way of doing it. So needless to say that for cloud hosted scenarios, requirements also extend to the network throughput, the bandwidth. So the camera network should upload the data to Scylla servers flawlessly. And yeah, so that's each solution has its pros and cons, and the choice depends on customer preferences, on par with the use case specifics they are interested in, such as price, physical installation efforts, security, the latency they are ready to go for, the lag between the event and the analysis, to name a few. So yeah, all of this have to be taken into account prior to making the final decision. Okay. So with this, I think I covered most of what I intended to introduce today. Thanks for joining us today at our webinar dedicated to Scylla Smart Intruder Detection System and its branch deviations. Please feel free to visit our website at scylla.ai to learn more about our technology and special suits tailored for different industries. You will find different products there, not only intrusion detection. There we have, at least I will name a few just to get probably your attention on that. Like there we have the preventive threat detection. Basically, it's, let's say, weapon detection. Anomaly detection system that, again, to speak basically, you can, for example, as an example, you can detect fight. You can detect harassments, and you can detect shoplifting and stuff like that. So you will find all full description on the website. Also, we have a body temperature detection solution, which is a part of this pandemic-related solution. Comes together with mask and mask detection, social distancing, social rule obedience. So all of this is there on the website. Feel free to browse and see the use cases. And where they are already installed and how people use it, etc., etc. And as I said, quite soon I will make another webinar dedicated to anomaly detection module, which is based on analysis of the action itself. Okay, so please subscribe to our YouTube channel to make sure you don't miss out on our new products and updates. And thank you for your attention. Thanks.